Assalamu alaikum students. Today we will cover paper 4 second variant of October number 2025. Question number 1. The three states of matter are solid, liquid and gas. Complete table 1.1 to describe the structures of solids, liquid and gases in terms of the particle arrangement, particle separation, particle arrangement and particle motion. So here we have to describe the words here, or we have to write the words here which will indicate their properties. So for solid, the particle arrangement, we can expect that if it is random over here, then in case of the solid, it is not random. Rather, we remember the particles were present in the orderly form. I would say orderly, or they are present in a fashion, or more precise word would be a uniform. They are present in a uniform manner. So you will write here uniform. Then particle motion for solid, if it is random for the gas, then for solid it is not random. Rather, it can only show a vibratory motion. Vibratory motion is exhibited by the solid. Then for the liquid, particle separation, it is if it is touching for the liquid, then for the liquid it is also touching, because the particles were very closer to each other, although not in the very uniform manner, but still they are very closer together. So you will write here touching, they are also touching. Then particle arrangement, in the case of the liquid, it is not the uniform, because the particles are not in a very orderly form, rather they are randomly arranged. So you write random. Then about the particle motion, so just like gases which can move in any direction, these liquids can also move in any direction. So you will write random here. And then gas, the gas is basically not touching, rather they are present at a distance, at a very larger distances from each other. So because of that reason, we write they are very apart from each other, because that they are like this one, the gas particles are very far from each other, something like this. Then B part, substances can physically change, name each physical change, solid to a liquid. So solid converting into the liquid is called as melting. When a gas converts into a liquid, it is a condensation. When a solid converts into the aqueous, mind it is not a liquid. The students can easily be mistaken by this word. It is written clearly as aqueous, not a liquid. If the solid is converted into the liquid, is already mentioned in the first point. But when it is converted to aqueous form, it means the solid has been dissolved in H2O solvent, dissolved in H2O water solvent. So this thing is called dissolve. This is also a term that is relating with the physical change. Dissolve is the word for the physical change. Then C part, describe in terms of particles why gases diffuse. So the diffusion of the gases, as we know, is because the particles are able to move in a very randomly manner and in all the directions. So we can say because of their movement. because of motion or because of movement. They show the process of diffusion. Then part 2 state what determines the relative rate of diffusion of gas at constant temperature. So if we remember from the literature, the diffusion was actually related with the mass of the gas. Diffusion is inversely proportional to the relative molecular mass of the gas. So you will just write here relative molecular mass or just MR. Then D part, gaseous oxides of nitrogen are atmospheric pollutants. One adverse effect of oxides of nitrogen is the formation of acid rain. State two other adverse effects of oxides of nitrogen. We have the we need to consult the literature if we have to understand this part. So I will take you to the literature, and here in the literature you can see the adverse effects of the nitrogen oxide mentioned over here. We see it is creating acid rain and then photochemical smoke and respiratory problems. So these are three adverse effects or the problem caused by the nitrogen oxides. So we come over here. So here we have to write the photochemical smoke. One is a photochemical smoke, and the other one lungs problem or breathing problems. Lungs or breathing problems. That's what we learned here. Or more precisely, respiratory problems. Lungs, breathing, or respiratory problems. Then E part, in catalytic converter, oxides of nitrogen are removed by reaction with the toxic gaseous product of the incomplete combustion of hydrocarbon fuels. Two non-toxic gases are formed in this reaction. Name the toxic gaseous product of the incomplete combustion of hydrocarbons. So as a result of the incomplete combustion of hydrocarbon fuels, there is just one toxic gas, if we remember, which is carbon monoxide. And you have to write the name, do not write the symbol. So the only toxic gas is carbon monoxide. And remember, CO2 is not the product of incomplete combustion and it is neither toxic. N2 is neither the product of incomplete combustion nor it is toxic. CH4 is not the product, it is the reactant and it is toxic, but it is not the product. So you have to be precise in giving the answer. Then part 2, name two non-toxic gases formed in the catalytic converter. So catalytic converter converts the unburned hydrocarbons, the nitrogen oxides into the less harmful gases. So those two non-toxic gases formed are carbon, and it also again says not the name. So carbon dioxide, and the other one is nitrogen. So these are the non-toxic gases produced by the catalytic converter. Then moving forward, question 2, iron is extracted from the iron ore in a blast furnace. The iron, okay, now this question would be skipped. We do not have to attempt this question. We can do this question, C part. Iron can form two different ions. We have to complete the table. Again, we just have to look at the formula or the symbol. Just give me a second, please. So just write the number of protons of the iron. We have to go to the periodic table to find the value. In periodic table, we can see the iron's atomic number is mentioned over here, which is 26. So coming back to the question. So atomic number is 26 for iron 3 plus as well. Then neutrons, simply take the difference, 54 minus 26. So it is equivalent to 28. And for iron 3 plus, since they are 4 crater unit, 54 is now 58 here, so that's why number of electrons will be 32. And then electrons, there's 2 plus charge over here, so electron will be 2 less, so it will become 26. And here it is 3 plus charge, so the electron will become 25. We then skip the remaining parts because they are already covered in the previous topics. We now move straight to the organic chemistry. Question number 5. This question is about the homologous series of alkanes. 3 general characteristics of alkanes are given. They are generally unreactive because they do not have a functional group. They have short trends in their physical properties such as melting and boiling points. They have similar chemical properties. Describe 2 other general characteristics of the homologous series of alkanes. So we remember alkanes have a single general formula. The general formula will be the same. For all the functional group which we have covered in the organic chemistry, they all have the general formula. So we can write the general formula here, which is CnH2n plus 2, that belongs to every member of the alkene. We cannot write functional group here because there is no functional group for alkanes. Since all the atoms in the alkanes have carbon-carbon single bonds or carbon hydrogen bonds, this is not a functional group because these bondings are present even in the alcohols. They are also present in the case of the carboxylic acids. So it's not the functional group here. So you cannot write these things over here. So one point could be the general formula. The other one is about that any 2 members of a single functional group have a difference of minus CH2, sorry, dash CH2 dash. What does it mean? It means that there is a difference of 1 carbon atom and 2 hydrogen atoms. Let's suppose if I take a propane and a butane, propane is CH3, CH2, and CH3. Whereas butane is CH3, CH2, CH2, and CH3. So you can see I have taken these 2 examples, propane having 3 carbon atoms and butane having 4 carbon atoms. So the only difference between them is CH2 difference. There is 1 carbon less and 2 hydrogen atoms less in the propane. So this is what it means, CH2. Then B part, state the trend in the boiling points of the alkanes as the carbon chain length increases. You have to state the trend, which means you have to tell what would be the trend. What would be the trend here? You do not have to give the reasoning. It does not require reasoning here. It just requires the thing whether it will be increase or decrease whatsoever. So you will write yes, the boiling point of the alkane increases as the chain length increases. So it is an increasing order. increases or just increasing. You can just write increase. Then part 2, name one other physical property of alkanes that show the trend other than melting and boiling points. Describe this trend as a carbon chain line of the alkane increases. So they have mentioned two physical properties here. One is the melting point and the other one is boiling point. Apart from that, we also have the solubility in the organic solvents, and another one is the diffusion. So you can write diffusion. Another property is density. So both of these things have different or have their different trend. They have asked you describe this trend, whether it would increase or decrease. This is what it would mean. So you will write if you write the diffusion, you will write the diffusion will decrease as the uh, as the chain length of the alkane will increase. So as the increasing chain length, the diffusion will decrease. But in terms of density, you can write it will increase, because as you are adding more and more carbon atoms, they become uh, converted, or they show physical state into the liquid state. The particles change from liquid state to the from solid to liquid state. Sorry, my mistake. It converts from gas to liquid and then into the solid state. As you increase the carbon atoms, this is the order of the physical state change: gas to liquid and liquid to solid. And this shows a higher density. It has the highest density because they shows high maximum mass in a limited volume. Highest density over here and lowest density over here. Then C, state why alkanes are described as saturated. So alkanes are saturated only because all the carbon-carbon bonds are single bonds. They are no double bonds like this, and they are not triple covalent bonds between them. So because of carbon-carbon bonds are all single bonds. Then D part, propane has structure formula, this structure formula. When propane undergoes a mono substitution reaction with chlorine at room temperature, two organic products can be formed. State one condition needed for this substitution reaction to take place. Okay, so if you go to the literature and right over here, you can see that condition required for the condition required for the substitution reaction is basically sunlight. You can have sunlight or you can have UV light. Both are possible and correct answers. You can either write sunlight or you can write UV light. UV is the short form of the ultraviolet. UV stands for ultraviolet. So one condition needed for this reaction to take place is the UV light, or you can also write sunlight, even though it's not mentioned in the mark scheme, but still it is a correct explanation. It's the correct condition. Then it says give the structure formula and state the name of each organic product formed. Structure formula product 1 and structure formula product 2. So here we are reacting the propane. We are reacting the propane uh, with the chlorine. So you should remember what would be the products. I'm writing the displayed formula here. C with 3 carbon atoms. This is for propane. I'm writing the structural formula of propane. So carbon 3 hydrogen atoms, and then with 2 hydrogen atoms, and then again with 3 hydrogen atoms. Now, as a result of the reaction with the chlorine, it shows substitution, which it means any one of these 6 hydrogen atoms can be replaced by the chlorine. These 6 hydrogen atoms all have the same position. If you go from left to right or you go from right to left, they all are at the same position. So you can take out any one of these 6 hydrogen atoms and it will give you one kind of a product, or you can replace these 2 hydrogen atoms and that will give you another kind of the product. So in the product one, I will write this structure formula, CH3, CH2, CH2 and Cl. What I have done here, I have basically removed the one of these 6 hydrogen atoms with a chlorine. That gave me this product. They ask you to write the structure formula. It's up to you whether you write in this manner or you write in the display formula. Now you have to give the name as well. So the name of this product will be according to the position of the chlorine. The chlorine is substituted in carbon number 1. So the name will become 1-chloropropane. This is 1-chloropropane. Then the second isomer that will be formed is by removing any one of these 2 hydrogen atoms in the center of the propane. So you will get a product like this CH3, then CHCl, and then CH3. Now here I have substituted one of the 2 hydrogen atoms present in the center. Now the name of this compound, since the chlorine is present on position number 2, so it will now become 2-chloropropane. 2-chloropropane. Then part 3, the 2 products formed are structural isomers of each other. Define the term structural isomer. So structural isomers are those compounds or having the same molecular formula but different structure. They are considered as a uh, compounds with same molecular formula but different. You can either write with different structures or different structural formula. Or structures. Both mean same thing. Then question 6. One on figure 6.1, draw a circle around all the atoms which make up the ester linkage. So this is an ester compound. You have to indicate the circle of the ester. You remember the ester is made up of this carbonyl group and then this carbon oxygen single bond, but it's not complete yet. You have to include another carbon. So I'm encircling this part first and then I will add one more carbon because the ester linkage is something like this, RCOO and then C. Now this C must be included, which means you have to include this carbon. You have to include this carbon. So the whole circle will be comprised over this whole region. So it has now included 2 oxygen atoms and 2 carbon atoms. Why did I not include the carbon of the left side? The reason is that if I encircle this carbon along with the oxygen, it does not show what would come over here. What would come over here? I instead of carbon, if I write H over here, then that can also that will be a different functional group, and this will be the carboxylic acid. This is a different functional group as compared to ester. So carboxylic acid has COOH. So that is not a correct answer if you encircle this carbon along with these three atoms. You have to encircle this carbon with the other three atoms. That is the correct circle of the ester linkage. Then it says name the compound E. So this is compound E, and we remember it is having this part called as ethyl, and the first name is written which is bonded with the oxygen through single bond. So you write the first name of this part and then second name of this part. This is the second name and this is the first name of the compound. So first name is ethyl and the second part, it is having 4 carbon atoms. So you write butanoic, butanoate, ethyl butanoate, and you can join the two words together. C says deduce the empirical formula of the compound E. How would we deduce the empirical formula? We just have to count the number of carbon atoms and hydrogen and oxygen. So we have how many carbon atoms? 1, 2, 3, 4, 5, 6. We have 6 carbon atoms. And then hydrogens we have 3, 5, 7, 9, and 3, 12. We have 12 hydrogen atoms. And oxygen are 2. Now its empirical formula will become C3H6 and O by dividing with the 2. So this is the empirical formula C3H6 and O. Compound E is produced when two different compounds react together in the presence of a catalyst. Name the two compounds that react together to produce compound E. So since ester is formed by the combination or by the reaction between an alcohol and the carboxylic acid, we can see from here the alcohol part is this part. This is the alcohol part. And the carboxylic part is this one. So just write the names of the relevant alcohols and carboxylic acid. So it has ethanol, and the other one will be butanoic acid. These react together to produce this compound E. Then part 2 suggests a suitable catalyst for this reaction. So this reaction occurs in the presence of the acid. E part determine the number of unbranched ester which have the molecular formula C5H10O2. So this compound had this formula C6H12O2, but the other ester which they are telling or which they are mentioning over here, it has one less carbon, which means the ester is made up of one less carbon atom. Now I have to make some structures here to arrive to the correct answer. I will just make simplified versions of the structures of the esters. For example, 5 carbon atom would mean that there will be 2 carbon atoms of the carboxylic acid and 3 carbon atoms of the alcohol part. So this is one kind of the ester. Its name can be propyl ethanoate. This will be propyl ethanoate. They are not demanding to write the name. I'm just explaining how the name would be. So this is one kind of ester. Another possibility would be I have one carbon atom on the left side, which means one carbon, not one, I will write 3. So 3 carbon atoms like this, and then 2 carbon atoms on the other part of the alcohol. So this is another ester. This is another ester here. Another way by which I can get is I have only one carbon on the alcoholic part and 4 carbon atoms on the carboxylic part. So 1, 2, 3, and 4. So 4 carbon atoms on the carboxylic acid part and 1 carbon on the alcoholic part. So this is third ester. Now the fourth combination or the fourth possibility would be when I have just 1 carbon atom on the carboxylic part and 4 atoms on the alcohol part. That means I would have something like this, HCOO, like this, and then 1, 2, 3, and 4. This is the fourth combination, the fourth possibility of the ester. This is also an ester. Why is it not carboxylic acid? You can clearly see that this carbon is bonded with carbonyl group, or this is a carbonyl group, and this is O. This is H. H is not bonded with O. If it was something like this, then you could say this was a carboxylic acid. But this is a carboxylic acid. This is carboxylic, but this one is not. This one is not carboxylic because this is a different arrangement here. So this is how you get 4 different possibilities of the ester with this formula C5H10O2. So you will write here 4. You have to write the number of unbranched ester, and they also ask you unbranched. These are all unbranched. But what it does it mean? You can see that this is a whole straight chain here. There is also a straight chain over here, and there is also a straight chain over here. So these are all straight chain. There is no branching. Branching could be something like this. If I convert this thing into a branched ester, it would be something like this. I would have branch over here, a branch over here, a branch over here. This is the branching. So I have not made any such ester having a branch. Then F part, all branch ester with the molecular formula C5H10O2 combust completely to form the carbon dioxide and water. Write a simple equation for the complete combustion. So here, complete combustion means uh, it will react with the oxygen C5H10O2. This is an ester with its molecular formula. It will react with the oxygen, and the only products formed will be carbon dioxide and water. There is no carbon, there is no carbon monoxide. So CO2 plus H2O. Now the thing is that the reactants and products are mentioned, but it is still incomplete in terms of the balancing. You have to balance the equation. So the rule is that whenever you have a complete combustion reaction, always remember the carbon first, then hydrogen, and at the last oxygen. So I will balance the carbon first. So I have 5 carbon atom on the reactant side. So to balance it, I need to multiply carbon dioxide with 5. So carbon atoms are now balanced. Now balance the hydrogen atoms. There are 10 hydrogen atoms on the reactant side, and on the product side I have 2. So I will multiply this reactant this H2O with 5. So I get 10 hydrogen atoms. Now balance the oxygen atoms. On the product side I have 5 times oxygen over here and 5 times 2. So this is 10 plus 5, 15. I have 10 plus 5 is equal to 15 oxygen atoms on the product side. Now balance this on the reactant side. In the reactant side there is already 2 atoms over here, and there are also 2 atoms over here. Now you should not put any number uh, you should not put any number over here unless other atoms are not disturbed. So if I put 2 over here, it will convert that into 10 carbon atoms. So let's see, if I do this, I get 10 carbon atoms. So 10 carbon atoms balance over here. And then hydrogen atoms are also changed. So it is 10 times 2, 20. So 20 would mean I have to also put 10 over here. not 5, it will become 10. So 10 times 2. Now 20 hydrogen atoms. Now let's see how about oxygen atoms. On the product side, we will have a new value for the oxygen atoms. So on the product side, there is 10 times 2 is 20, 20 oxygen atoms coming from here, and 10 times O over here. So 10 plus 10. So there are total 30 oxygen atoms. 30 oxygen atoms on the product side. Now balance it from the reactant side. So we have 2 times 2, 4, and 2 over here. So I can easily convert this value into 30 by multiplying this value of the O2 only. So 4 is already coming from here. Now 4 is already coming from here, and I'm left with the 24. There is still 24 value less, which means I will multiply this value with 12. No, I will multiply this value with 13. 13 times 2 gives me 26. So I was left with only 4 more oxygen atoms. So 13 times 2 is equal to 26. So 26 oxygen atoms coming from this part, and then add with the 4 oxygen atoms coming from the ester part. So in this way, this equation is now balanced. So the final form of the equation is 2 times of the ester, 13 times of the O2, and 10 times of carbon dioxide, 10 times of the water. So in this manner, this equation is now completely balanced. So that was all for today, students. If you have any query, you can let me know in the comment section, and you can also reach me out to my WhatsApp number. And if you require my notes of the whole all levels at IGCSE, you can reach me out for all whole organic chemistry or other chapters. So that's all for today, students. Till our next class, take care and bye bye.